Alright, this video is going to cover Objective 4 in Chapter 2. It's going to be all about being able to calculate the number of subatomic particles in an atom. So just quick review from Video 1. Atoms are the basic unit of matter. Remember, they're the first level of organization. Atoms make up everything. Atoms make up molecules and compounds, which make up macromolecules. And they are the smallest unit of an element. So if I have hydrogen or oxygen or carbon or nitrogen, I can essentially have one atom of that element, and that's the smallest unit that I can have. So remember, you have a handout in your packet if you want to kind of get that out and take a look at it. But inside you have the nucleus, and the nucleus consists of the protons and the neutrons. And then around the outside, and what we call the electron cloud, you have your electrons. And you can find those in different energy levels, okay? Now on the periodic table, it provides us with some important information about each element. And so each element is represented by a symbol, and that symbol is always going to be either just a single capital letter, like in the case of carbon, in the case of oxygen, or it could be a capital letter followed by a lowercase letter, like sodium is capital N, lowercase a. Iron is capital F, lowercase e. But each element is always going to have one capital and either just one capital or one capital and a lowercase letter with it. Now there's also going to be some numbers on the periodic table. Sometimes the name is there, sometimes it's not. It just depends on what table you're looking at. You do have a periodic table included in your handouts, but there's going to be some important information in the form of numbers on your periodic table. And so the element is defined by its atomic number, and that's always going to be the whole number. Sometimes it can be in different locations. Once again, it depends on what your periodic table is, but it's always going to be the whole number, and the elements are numbered in order, so that one's pretty easy to find. So the atomic number is the number of protons, and we said in video 1 that protons determine the element. So if a particular atom has 6 protons, then it's always going to be carbon. If it has 8 protons, then it's always going to be oxygen. If it has 1 proton, it's hydrogen. If it has 11 protons, it's sodium. And so essentially, the element is defined by the protons. Okay, and that's never going to change for that element. That particular element always has the same number of protons in its atoms. Now, the other number, if you notice, it kind of has decimal points. And so that is what we call the atomic mass. And once again, if you go back to video 1, the subatomic particles that contain mass are your protons and your neutrons. And remember, these were found in the nucleus. So essentially, the atomic mass is the mass of the nucleus of the atom, which consists of the protons and the neutrons. Now the reason it's a decimal and not a whole number is because it's an average. Not all atoms of that element have the same numbers of neutrons. They can vary. We're going to talk about that in a later video. But the average just comes from the fact that the neutrons can vary from atom to atom of that same element. And so anytime you're using the atomic mass, if you're trying to calculate the numbers of neutrons, things like that, which we're about to do, you're just going to want to round that number, okay? Just always round it to the nearest whole number. If it's less than 0.5, we're going to round down. If it's 0.5 or greater, we're going to round up. So the mass for carbon, we could say is 12, and the mass for oxygen, we would say is 16. All right, so we've covered the protons, okay? The protons are the atomic number, and we've covered the mass, and we said that was protons and neutrons. Well, if I know the mass and I know the protons, then I can easily find the number of neutrons by just simply subtracting. So anytime you want to find out how many neutrons are in a particular atom, you just take the mass, which is protons and neutrons together, and you subtract the atomic number, which is just protons, and you now know the number of neutrons. So over here, you have a couple examples. Iron has 26 protons, its atomic mass, we would round up to 56. We subtract, and we know that iron has 30 neutrons. Once again, protons never change, okay? It's always going to be that atomic number. Same thing down here for helium. Helium has an atomic number of 2, therefore its protons are 2. We take the mass and we round that off to 4, so 4 minus 2 gives us 2 neutrons. So just kind of a general review of what we just covered. Okay, protons are the atomic number. Protons and neutrons are the atomic mass, and so we can just subtract to find out how many neutrons we have. But what about electrons? Well, we mentioned earlier that atoms are neutral. Okay, so let's go back to their charges. We have to remember that introductory information. Protons were positive, electrons are negative. Okay, so if protons are positive and electrons are negative, in atoms, if they're neutral, that means that they don't have a charge overall. That means your protons, your positives, must be the same as your negatives. Okay, so if you're trying to determine the number of electrons in an atom, it's always going to be the same as the number of protons. And that way, the positives and the negatives balance out. All right, so here we have a nucleus that has 4 pluses. Okay, it looks like maybe some of them, it's carbon, so there's actually 6 pluses in there. And then you notice around the outside, you have 6 electrons. So carbon has 6 protons, therefore it has 6 electrons. All right, so let's do some practice. We're going to do several of these. So what is the proton number of iron? Okay, we're going to find our atomic number, which in this case is 26. And then what is the number on the periodic table? What number on the periodic table tells you how many protons an element has? Well, that's this number here, and we call that our atomic number. And then which 2 elements on the periodic table have the same number of protons? Now, you should have a periodic table handy, and if you want to take a quick glance, you can, but just for time's sake, I'm going to go ahead and move forward. But protons determine what the element is. If the protons change, it's not the same element. So number 3, the answer is none, okay? Different numbers of protons equals different element. All right, so some more practice questions. How many protons and neutrons does fluorine have? So here we have our atomic number. We have 9. We take our mass number. In this case, we're going to round up. So to find the number of neutrons, I simply subtract. So 19 minus 9. How many protons and neutrons does potassium have? Well, there we have our protons, 19. We have our mass, which is 39. We subtract our 19. And there's our answers. All right, some more practice. This time we're going to look at electrons too, okay? So how many protons, neutrons, and electrons? So protons is always going to be the atomic number. To find neutrons, we take the mass. In this case, we would round it to 24. And neutrons would be 24 minus 12. And then electrons would be the same as the protons. Whatever the protons are, that's what your electrons are going to be, okay? Same thing on number 2. Protons is the atomic number. For neutrons, in this case, we'd round to 65. 65 minus 30 is going to give us our neutrons. And then the electrons will be whatever the protons were. So there's your answers. All right, one more for practice. So calculate the number of protons, neutrons, and electrons for sodium. So protons is the atomic number. Neutrons is going to be the mass. So 23 is what we'd round that up to. 23 minus 11. And then the electrons will be the same as the protons because the atom is neutral. And there's our answers there. All right, so one more thing we need to talk about, and for this particular objective, and that is valence electrons. Now, earlier in that model, I kind of showed you how that the electrons are kind of found in different energy levels. And so we're not going to go too involved in this. We just kind of need to know the basics here. But the first energy level around the nucleus can hold 2 electrons. And then after that, the other energy levels can hold 8, okay? And so valence electrons are the electrons that are on the outermost energy level, okay? They're the furthest away. They're the most loosely held. So remember that the nucleus is positive because you have protons and neutrons there, and the electrons are negative, so it's that attraction that holds these electrons. It's what keeps them from just flying away off into space. And so the further away that electron gets from that positive nucleus, the more energy it has. It's just kind of not quite as tightly held, and so that's what we call our valence electrons. And so these are the electrons that determine how the atom behaves. It determines what the atoms will or will not bond with. And the reason why is because atoms want a full outer ring. They want that outer shell to be completely full. So for most atoms, that's going to be 8 valence electrons. There's a couple of exceptions, and that's hydrogen and helium. They only want 2, okay? But everything else is going to want 8 valence electrons in that outer shell. That's kind of what makes an atom happy. I know that's not the appropriate terminology, but that's how I always like to think about it. And so if we look at a couple of examples here, based on the atomic structure, how many valence electrons does sodium have? So sodium has 11 protons, which means it's going to have 11 electrons. So 2 go on the first ring, and then we put 8 on the next ring, and that would be 10. And so our 11th electron goes out here on the next ring, okay? So valence electrons are the ones on the outside. So how many valence electrons does sodium have? It's that little dude right there, okay? Now, does sodium have the 8 valence electrons that it wants? Does it have 8 on the outer shell? And the answer to that is definitely no. And we'll talk about later why that's important. All right, so some more calculations. All right, we have the number of protons, atomic number. We have neutrons. We take our mass, which in this case we'll round down to 35 minus 17. And once again, protons and electrons are going to be the same. So there's our answer there. Now let's take a look at the valence electrons. So chlorine had 17 protons. So we have the first outer shell holds 2. The first shell holds 2. The next shell holds 8. Okay, so that would be 10. So the remaining 7 are going to go on the outside. And so we can count them. There's 1, 2, 3, 4, 5, 6, and 7. So chlorine has 7 valence electrons. Once again, does it have the full outer shell? The answer is no. And we're going to stop there. Okay, this one does not have 8, and we're going to be moving on to Objective 5 in the next video.